Alright, today let's have a little fun with graphing inequalities. Remember, inequalities are your greater than and less than signs. So let's make a note of this here. How to graph inequalities. For example, if you have x is greater than or equal to -2. Okay. So here, your good old number line. Your 0 would be here, right? 1, -1, -2, -3, and so on. X is greater than -2. So actually, this is greater than or equal to -2. So let's make a circle there, and let's fill in the circle, make it a solid circle. Greater is to the right. Okay. So this is what we call a closed circle. A closed circle. So if you have a closed circle, like we do there, includes the number. The number -2. Okay? So anything greater than or equal to -2 will be part of our equation there. Okay. Occasionally you might have an open circle. Since we're on this topic here, let's talk about it. If you have an open circle, we're going to show you an example here in just a bit. Includes, let's say an open circle does not include the number. Okay. Does not include the number. Okay. For example, if you have x is less than 3, okay, so again, the number line, let's say 4, 3, 2, 1, 0, -1, okay. If x is less than 3, first let's draw a circle at 3. If it does not include 3, we're going to leave it an open circle. And then, since it's less than, draw arrow to the left like this. Okay, so this is an open circle. Okay. Sometimes you might see a 2-in-1. For example, you have x is less than -4, or x is greater than -1. Okay, so if you were to graph out this line here, you would find your place at -4, -1, and usually it's good to have 0 as a reference here. Okay, so let's focus on one at a time. If x is less than or equal to -4, let's make a circle at -4. Is it going to be a closed circle or an open circle? Since it includes -4, we're going to have a closed circle. Okay, less than take us to the left. Okay, so this is a closed circle. Now, x is greater than -1. Let's start off with a circle. Since it does not include -1, we're going to leave this as open. And greater take us to the right side. Okay, so let this sink in. And I think this is where we're going to talk about some properties of addition next. Okay. So hopefully you are able to understand that okay. Let's look at a couple tricks we can play with, like when we are adding numbers. So the first property that we're going to look at is the property of addition associative property. Okay, so what is the associative? Property of addition. This is the name of a property, so let's capitalize the first letter there. Okay. So this is where you're changing the order of the additions. Okay, so let's make a note here. You're changing the order of the addition let's look at some example. So if you have 3 plus 5 in parentheses plus 1 equals 3 plus 5 plus 1, but this time we're moving the parentheses, shifting it to the right. Okay, so let's see what we end up with here. If you take 3 plus 5, you get 8, right? Plus 1 equals 3 plus 5 plus 1 is 6. 8 plus 1 is 9, equals 6 plus 3 is 9. So according to this associative property of addition, even if you change the order in which you are adding, you're still going to get the same result. Alrighty? So where there's associative, you're going to see what's called the commutative property of addition. Commutative. Okay. Property of addition. This is where you're changing the order of the numbers. So, as opposed to changing the order of the additions, you're changing the order of the numbers. So, here's an example. 4 plus 2 in parentheses plus 7 equals 2 plus 4 in parentheses plus 7. Okay, so this is pretty logical where, well, you know what, before I give it away, let's see if we can just figure it out ourselves here. 4 plus 2 is 6, plus 7 equals 2 plus 4 is 6, plus 7, 6 plus 7 is 13 equals 13. So now you can see that according to the commutative property of addition, even when you change the order of the numbers, here is 4 plus 2, here is 2 plus 4, is either way you're going to get the same result. Okay? So let me save a little writing here and then just change this to inverse. What is the inverse property of addition? give it all to you here. This property states that a number added to its opposite integer equals 0. Notice that I'm writing this down, and I'm hoping you are too, because I don't remember this. So best sometimes if we write stuff down. Okay? So for example, 3 plus negative 3 equals 0. Okay. So according to this inverse property of addition, a number added to its opposite integer, so a number added to its opposite integer equals 0. And you can justify that by saying that 3, remember when we have a plus and a minus next to each other become minus? 3 equals 0. So 3 minus 3 is equal to 0, equals 0. Okay. Negative 5 plus 5 equals, well, a number added to its opposite integer. So here's a number. The opposite of negative 5 is 5. According to this property here, our answer is 0. Okay. Just a little something for you to chew on here. The next property that we are going to discuss is called the identity property of addition. Identity property of addition, which states that any number added to 0 is the number itself. Okay? Any number added to 0 is the number itself. So for example, 0 plus 4 equals 4. See? A number 4 added to 0 is itself. Negative 11 plus 0 equals negative 11. Okay. What's the difference between an equation and an expression? Expression. Okay. So here's the key to it all. An expression does not have the equal sign, less than or greater than symbol. Okay. So I'm going to throw some example at you and see if you can indicate whether it is an equation or an expression. Okay, so for example, 3x minus 1. Is this an equation or an expression? Do you see an equal, less than, or greater than sign here? Nope. So this is an expression. Okay? Since there's no equal sign, nor is there any greater than or less than sign. What about 5 plus 4y equals 17? Is this an expression or an equation? There's an equal sign there. So this makes it an equation. Okay. 6x minus 5 is less than negative 2. Okay. Check to see if there's an equal, less than, or greater than sign. There is. So this is an equation. Okay. One more. 8 minus negative 10y. Is this an expression or an equation? If you say expression, you are correct. You don't have any equal, less than, or greater than sign there. Good job. Okay. So we're going to leave inequalities for now. Let's talk about translating words into numbers. Sounds fun, right? Because it is. So, how to translate words into numbers. First, let's look at some keywords here, like sum, difference, product. What's the other one? Quotient. Okay, so sum means add. You're going to add two numbers to get the sum. As opposed to difference is subtract. The product is the answer to a multiplication problem. Quotient is divide. So the answer to a division problem is the quotient. Okay, so let's look at some example here. Let's say 4 times the sum of x and 7 of x and 7. Okay, so 4 times the sum of x and 7. Okay, x plus 7 times 4. 8 less than the product of y and 5. Of y and 5. Give that a try. Push pause on this clip and see if you can translate this into an expression. Okay, so the product of y and 5 is taking y times 5. You can say is 5y. 8 less than that. So you can say minus 8. Okay? What about twice the sum of 9 and x? See if you can try to figure out this one here. Make it an expression. Remember, sum means add. So take 9 plus x. Twice that amount. So multiply it by 2. Got it? Feeling okay on these? Just in case, let's look at some more. Let's say 10 times the difference of y and 6 of y and 6, let's say it's 80. Okay, give that a try. The difference means we're going to subtract. Okay, y minus 6 10 times that. 10 times the difference of y and 6 is equal 80. Got it? Gets funner. 3 times x is more than 16. Okay. 3 times x, we'll say is 3x is more than, greater than 16. Like that. This one is just for you. The quotient of 25 and y is less than 8. Okay, give that a try. Translate it into an expression. Actually, it's an equation because you have less than here. So, okay. Quotient means divide. So take 25 divided by y is less than 8. Okay. Notice the question did not say solve, so we can just leave the expression alone here. Okay. Leave the equation alone. We're moving right along here, guys.